Today we're going to be learning about scientific notation. So before we begin, let's look at some vocabulary words that you need to understand before actually writing numbers in scientific notation. First is the definition of standard form. Standard form is the way that we normally write numbers. This is also known as standard notation or decimal form. Next is scientific notation. Scientific notation is a way of expressing numbers that are too large or too small to be conveniently written in standard form. It's also known as the product of a number between 1 and 10 and a power of 10. The last vocabulary term is product. Product is the answer to a multiplication problem. So here is a number that's written in scientific notation. We read this as 5.2 or 5 2/10 times 10 to the 9th power. Here is that number written in standard form. We read this number as 5,200,000,000. So the one on the left is scientific notation, written as the product of a number between 1 and 10 and a power of 10. And then on the right is standard notation, or the normal way that we write numbers. So scientific notation is made up of 3 parts. The first part is the decimal number at the far left of the number. Our decimal number in this example is 5.2. We call this the coefficient. The coefficient when writing scientific notation must be a number that is greater than or equal to 1 but less than 10. This is the rule for the coefficient so that every time that we write scientific notation, we write it in the same format. The next part of scientific notation is the 10, which is called the base. When we're writing scientific notation, the base will always be the number 10. The last part is the 9. The 9 is called the exponent. In scientific notation, the exponent tells us how many times we moved the decimal and in what direction. So let's look at an example. Our first example is 5.8 times 10 to the 6th power. We want to write this number in standard notation. Our first step is to rewrite the coefficient. So I boxed in the coefficient, which is 5.8, and we're going to write it below. The next step is to look at the exponent, and we're going to move the decimal point that number of spaces. If the exponent was positive, then we're going to move the decimal point to the right. And if the exponent is negative, we will move the decimal point to the left. So I've circled the exponent, which is a positive 6. Since it's a positive number, we're going to move the decimal point to the right. So let's move that decimal point 6 places to the right. Now, after we move the decimal, we can't forget to put the decimal in its new place, so at the very end of those hops, and erase the original one. So I'm going to put the new decimal at the end and erase the one that was between the 5 and 8. Now we have all those empty hops that don't have any numbers in it, so we're going to add zeros. After we add those zeros, we're going to rewrite our number up top and add in our commas. So this number is 5,800,000. So that is the value of 5.8 times 10 to the 6th power. Let's try one more example. This example is 1.35 times 10 to the negative 4th. So our first step is to rewrite the coefficient. So box in the coefficient, which is 1.35, and we're going to rewrite it below. The second step is to look at the exponent and move the decimal point. Remember, if the exponent is positive, we will move it to the right. If it's negative, we'll move it to the left. So circle your exponent. The exponent is negative 4. Since it's negative, we're going to move that decimal place 4 spots to the left. So let's go ahead and move that decimal. We're going to draw 4 hops. So don't forget to put the decimal in its new position and to erase the old one. Lastly, we're going to add our zeros into all those empty spaces And don't forget to add a 0 to the left of the decimal. Now we're going to rewrite our answer up top. And there it is. The value of 1.35 times 10 to the negative fourth is 0.000135. Now let's go the other direction. I'm going to give you a number that's written in standard notation, and I want you to write it in scientific notation. So our first step is to move the decimal to make a coefficient that is greater than or equal to 1, but less than 10. So I'm going to rewrite the number below, and we need to figure out where our decimal is because there isn't one on this number. Well, anytime you have a whole number, the decimal is always located at the far right of the number. So now we need to move that decimal place until we create a number that is between 1 and 10. So if I stop moving my decimal right here, that creates the number 264. That number is not less than 10, so we need to continue to move it. Here we have 26.4, still not less than 10, so we move one more spot, and now we have 2.64. That number is greater than or equal to 1, but less than 10, so that's going to be our coefficient. So we're going to rewrite it above, and we don't have to write those zeros since there are no other non-zero numbers left over. So we have our coefficient. Then we're going to write times 10. Remember, scientific notation is always that coefficient times 10 raised to a power. So the last thing we need to do is figure out the exponent. Well, the number of spaces that we moved the decimal is the exponent. So let's count and see how many times we moved that decimal. You can draw the hops just like we did on the other two examples. So you can see that we moved that decimal 7 times. Now, if the original number was greater than 1, then that exponent is going to be a positive number. But if it was between 0 and 1, then the exponent will be negative. So if we look at our original number, it was 26,400,000. That number is definitely greater than 1, so our exponent is going to be positive 7. So put your positive 7 right beside of the 10. Remember, your exponent is smaller than the base, so it should be a small 7 by the 10. All right, let's try another example. This example is 0.000002. So we're going to write this number in scientific notation. So our first step is to move that decimal to make a coefficient that is greater than or equal to 1 but less than 10. So we'll rewrite the number below, and we need to figure out where that decimal can go to make a number between 1 and 10. Well, if I put it to the right of the first non-zero number, then it's always going to make a number between 1 and 10. You can see I put a decimal to the right of 2, and if I isolated that, that would just be the number 2, which is between 1 and 10, so that's going to be our coefficient, and we'll write it above in our answer. Our coefficient is always followed by times 10. Now we need to count our hops to determine our exponent. So we moved the decimal 6 times. Now we have to determine if that 6 is going to be a positive exponent or a negative exponent. Well, our original number was 0.000002. That's definitely less than 1, so between 0 and 1. So our exponent is going to be a negative. So let's write our negative 6 up by our 10, and that's our final answer. 2 times 10 to the negative 6th power. The last thing we're going to look at is how to compare and order scientific notation. So our first step when comparing and ordering these types of numbers is to look at the exponent, and we'll put them in order based on their exponent. Now, if one of the numbers or two of the numbers have the same power of 10, so the same exponent, then we're going to look at the coefficient instead. Now, there's 2 important vocabulary terms that you need to know before moving forward. Those are descending order and ascending order. Descending order means greatest to least. Like you're descending the stairs, you're going down. So from the highest number to the lowest. And ascending order means least to greatest. So going up from the lowest number to the highest number. Now, remember, when you're comparing and ordering numbers in scientific notation, you do not have to convert them to standard form. It's actually easier to leave them in scientific notation or to convert them to scientific notation. So let's look at a few examples of comparing and ordering. In our first example, we have 9.8 times 10 to the negative third and 2 times 10 to the fifth power. So the first thing we want to do is look at the exponents. The exponents are negative 3 and positive 5. The exponent of positive 5 is greater than the exponent of negative 3. The exponent of positive 5 is greater than the exponent of negative 3. So we're going to put the less than symbol between those two because the exponent of negative 3 is less than the exponent of positive 5. All right, let's look at example number 2. We have 7.31 times 10 to the fourth power and 7.3 times 10 to the fourth power. So first, we look at the exponent to compare them. The exponent tells us how many times we're going to move the decimal, so the greater the exponent, the greater the number. So our exponents for both of these are positive 4. Since they're the same, we're going to ignore the exponents and just look at the coefficients. So our coefficients are 7.31 and 7.3. So we could just look at the numbers and see if we could tell which one is greater or less than. But if you're having difficulties figuring out which one's the bigger number, you can stack them. So I've stacked them over in the margins. We have 7.31 on top and 7.3 on the bottom. Now 7.3 only has 2 digits, whereas the other one has 3. So we're going to add a 0 to the end of 7.3 to make them have the same amount of digits. So next we're going to cross out the columns that have the same values in them, and we'll box in the one that's different. So the first 2 columns have the same values, so we're looking at the column that has a 1 on top and a 0 on the bottom. Now 1 is greater than 0, so the top number is greater than the bottom number. So that means we're going to use the symbol greater than between these two because the exponent of 7.31 is greater than the exponent of 7.3. Last, let's look at an example of ordering. So this example says write the following numbers in descending order. So the first thing that you should notice is that 3 of the numbers are written in scientific notation and 1 is written in standard notation. Now I told you earlier it's easier to compare the numbers when they're in scientific notation because we just have to compare the exponent. So I want to change 3,800,000 to scientific notation. I want you to try to change that yourself before I put the answer up. All right, here's the answer. 3.8 times 10 to the 6th power is 3,800,000 in scientific notation. So now, the next thing we need to do is figure out what the word descending means. So that was one of the vocabulary words that we talked about. Remember, descending means going down, so that's going to be greatest to least. All right, let's start by looking at our exponents. So we have the exponent of 5, 6, another 6, and a negative 3. So we're moving from greatest to least, so we need to figure out the numbers that have the greatest exponent. We have 2 of them who have the greatest exponent, the exponent of 6. So since they have the same exponent, we're going to ignore that and we're going to look at the coefficient. So we have the coefficient 3.9 and 3.8. We're looking for the greatest number, so 3.9 is actually greater than 3.8, so this is going to be the first number in our list, followed by 3.8 times 10 to the 6th power. Moving on to the last 2, we need to figure which one is the greatest out of the 2. So looking at the exponents, we have the exponent of 5 and the exponent of negative 3. Since the exponent of 5 is greater than the exponent of negative 3, this is going to be the third number in our list, followed by the very last one that has the exponent of negative 3. So for our final answer, we're going to rewrite these numbers in their original form in the new order. So notice in the answer, I did not write 3.8 times 10 to the 6th. I wrote 3,800,000.